So this says y equals b to the x, b positive, b can't be 1. He is a 1-to-1 function, so he passes a vertical and a horizontal line test. His domain is, and this should be all real numbers, and increasing if b is positive. What does that mean? That means as long as b is positive, we're not flipping. Well, b has to be positive. That makes no sense to me. B can never be negative. Or bigger than 1, I'm sorry. Peterson. Bigger than 1. It's going to be between 0 and 1 that's going to have a problem. It flips. Asymptotic to the x-axis, or y equals 0. And that's what he looks like, and that's what we graphed 3 to the x, he looks just like that. This guy, and he has a y-intercept at 0, 1. His range is 0 to infinity. He's decreasing if I'm on the other side, and this is this guy right here. And that was 1/5 to the x, looks just like that. And why do we need to know that? Because we're going to be doing transformations, and this is where you guys are going to have to help me, because I know how I do transformations, but you may have learned it just slightly differently. And I take a look at wanting to graph y equals 3 to the x plus 2. The basic function is y equals 3 to the x power. His domain is all real numbers, and he has a horizontal asymptote. Oh, and this should be a -1. I didn't see that. A horizontal asymptote at y equals 0. That's your basic function. That's what you have to know if you're going to be doing transformations. What's your basic function? What's his domain? And does he have anything specific about him that's important? Like rational functions have vertical asymptotes. So if I take a look at this particular function, if I want to list the transformation, this is an x plus 2. So what happens to this guy? An x plus 2 does what? Left 2. I'm going to be looking here at a -2, and so he's going to be left 2. And then here's a -1 hanging off the edge, and a -1 hanging off the edge says what? Down 1. Now, how I tend to do transformations is I go off of the basic function. Some of you can kind of do it in your head. I'm not one of those who can do it that way. But if I take a look at the basic function has 3 important coordinates. It's got these 3 right here. It's a bend. That says you've got the bend, you've got the direction, and the HA. So if I have these 3 coordinate points and the HA, I can do a transformation. Why? Because this bends toward the HA, this one goes away from the HA. So once you have the bend, you have got the graph. The bend occurs at 3 coordinate points. X, 3 to the x, is -1, 0, and 1. 3 to the -1 is 1/3. 3 to the 0 is 1. 3 to the 1 is 3. So those are the 3 coordinate points for the basic function for the bend. Now that says, and then I need one more thing. I need to put in his HA. He has an HA at 0 because the HA shifts. So left 2 means I'm going to take the x values and I'm going to add a negative 2. So this would be negative 3, negative 2, negative 1, and HA, because you can't add a number to the letters. Down 1 means I'm now going to take the y values and I'm going to add a negative 1. This becomes negative 2/3, 0, 2, negative 1. Now notice that shifted my HA. So that if I look, on the outside is the new, so the HA is now at negative 1, and this is going to be the shift in the graph. So those are my new coordinate points. First thing I do is I put in my HA. Negative 3, negative 2/3. Negative 1, 2, 3, negative 2/3. Negative 2, 0. Negative 1, 2. Now there's your bend. That's the important part of that graph. Now it goes out and up, and this goes toward the HA, and that's your transformation. That's what it looks like. Does that make sense? No, yes? Maybe? Hopefully?
So I threw up like a 3 to the 1 over x into my calculator. Why doesn't that come out the same way? Why does that become a
3 to the
1 over x? Why does that do a
you're talking
rational
about
function?
that.
Yeah, why is that?
But this is really
rational?
3 to the minus x to the minus 1.
Okay.
So you don't have one of your basic transformations there because of the 1 over x.
Well, I'm just saying, like, I'm curious about, like, understanding how these exponential functions graph, and, like, if we transform by doing, like, a plus or minus or whatever, we can't stretch a exponential function by dividing?
No.
Okay.
Well, your exponential stretches and shrinks are going to be just like your stretches and shrinks on your regular function.
Okay.
So in other words, if I have a to the x, that's your basic.
Right.
Right? If I'm going to stretch or shrink it on the outside, right, I'm going to multiply by some constant.
Okay. So it'll be out there.
If I'm going to stretch or shrink on the inside, right, that's going to be, on the inside, stretches or shrinks, it's going to be by a constant times x. Because the stretch or shrink is a value that's multiplying the x value. So
right.
It's changing those x's. When you did x to the minus 1, you literally changed that exponent to be something which doesn't fall into the basics of the transformations.
Okay.
So when I see this, for me, I'll probably run. It's not too bad. I'd see this, I'd run more than anything else, because that would, that would not be fun to graph. Calculator time.
Yeah.
I guess